Hello, everyone, and welcome to Cars with Italians, where
Yes.
we discuss cars, apparently, and apparently also some code at some point, but mostly cars.
Well, it was a good backstage conversation, Sebastiano. So and it was
absolutely.
also very tech heavy. So you can laugh. Well, we were discussing autonomous driving. So that's
Were you?
the
I wasn't listening anymore at that point, I guess.
yes.
I was telling the chat that we were about to start. Come on, give me that.
Fair enough. Fair enough. So hello everybody.
Hey,
Hi,
Jake. Welcome back.
How you go? How you doing?
Yeah, thanks for having me back.
Thank you for installing Skype again.
Yes.
Yeah, if I disappear, it's because the work software has brought down the banhammer.
Yeah. Worst case scenario, we'll call you on the phone or something. I don't know.
Yeah.
We'll figure it out.
Yeah.
So besides cars, today we have you back because we are talking about Molecule. As I told Zach and Josh last week when they came to talk about Circuit, it's something that I heard of. I have no idea what it is about, and I'm very curious. So keeping in with our tradition of inviting people to explain things to us, because it's easier and also better than just trying to figure things out by ourselves. We got you back. So, I mean, by this point, you know how it works. I think just let's get even to do the even thing, and then we can jump straight in.
That's correct. So thank you. I want to be quick. I want to thank you everybody for the support, for the views, the comments. We are lately we are hitting some interesting number on YouTube as well. So thank you for the support. If you want to support us from a financial point of view, because you know Sebastiano wants a Tesla, you can buy.
I do not want a Tesla. I want a freaking Volvo, dude.
Just not a Volvo. What are you talking about? Anyway, so you can buy our keychains, or you can subscribe for free to our Twitch channel. If you have an Amazon Prime subscription, Uncle Bezos will gift you with a 1 month free subscription to any channel that you want. You just need to connect your Amazon Prime account to your Twitch account, and you will see a new toggle in the app that says subscribe for free. Subscribing for free basically will allow us to get some dollar to print stickers and to send you stickers when we do the giveaway, or just give you stickers when you meet us at conferences. We also have a merch store if you want like a t-shirt like this, or the Need for Speed designs that Sebastiano prepared for us. If you have a dog, you can buy a dog bandana with this design. Anything that you want, you can find it on the.
I mean, you can buy
store.
that bandana even if you don't have a dog. But
fair
it's
enough.
Be less useful.
but it says dog bandana. So I mean, the use case is very specific. So I mean,
sure, but we're not going to tell you what you can and cannot do.
Yeah, well, yeah. Do you? Anyway, thank you for the support. And again, if you're watching this on Twitch, think about subscribing. Oh no, Mark Edison just redeemed Delivano. Hello, hola todos. Bienvenidos a Carros con los Italianos. Coches con los Italianos. I think it's South America.
Depends. Yeah, which region you're talking about, I guess.
Anyway, thank you everybody, and if you're watching this on YouTube, subscribe and like. Thank you. Let's go. Molecule. I want to know, and the time is always running out very quickly. So
yes. Okay. So step one. What is Molecule?
Yeah. It came out of really two separate things. And I'll show the README here in a second, and we'll go through one of them. But I was actually working on at work as part of my day job, working on a different project called Redwood, which maybe we could talk about in a future show, because that's another crazy Compose thing.
You're doing
so
all the crazy Compose things, man.
Yeah, you don't even. Yeah, I don't. I shouldn't give this away yet, but I'm hoping to do something even crazier for my Kotlin Conf talk in 6 months. But
Okay.
we'll see. We'll see.
Let's
still
talk
not
about
sure. I'm
this
still not sure it's gonna
after
happen.
we are off air.
Yeah,
So
I'm gonna submit the talk, even though I haven't successfully pulled it off, and then I have 6 months to just make it
it's
work.
fine.
Yeah,
It's a good stress. It's the stress that you need to actually do things.
definitely. So this project Redwood at work is it's a Compose based tool, and it's not Compose UI based. It's just using Compose, although it is driving sort of the native UI toolkit of each platform that we run on. So Android, iOS, can do the web, desktop, whatever. But it's Compose, and so you're writing composables like you normally do, but the
MDM has caught up with him.
Oh man, for a moment I hoped it was my connection.
Nope. Nope.
Oh, but so what should I do? Juggle? I can't juggle.
Yeah, I will get Spike back. I don't know.
I don't know. I mean, he's downstairs because the kid is downstairs, and the kid is always eating something, so he's around food. I mean, you know how it is, right?
Yeah, I know.
Well, work computer has killed Skype. Damn it. Yeah, try the web version. Web version. Yeah, I mean, there is Skype for web. Yes.
It had to happen,
I mean,
right?
YouTube is gonna pick us for the girl from Ipanema that I was singing.
You're singing it way too well. It's like
copyright. The Fourier function is gonna match my humming.
Yeah.
So something different is why it crashed.
Yeah.
Yes. Let's hope.
Well, I guess so. I just put the link to Redwood in the chat.
Yeah.
I guess.
Can you share?
Yeah.
I'm gonna note down, but maybe you can show the
that's Jake's
readme or something.
Second. That and that. Okay. Yay, Redwood. So
I don't see this. I don't see the share, by the way.
Oh yeah, because I haven't shared it on Skype. Now you can see it. There you go. You're
Redwood.
welcome. Even you're welcome.
Redwood is a library for building. Thank you, Sebastiano, for reactive Android as well using Kotlin. Okay.
It's like Compose native. I don't know the way Jake was describing it. So I think what will happen is that we're gonna speculate wildly on what Redwood is, and then when Jake is back, he's gonna tell us we were wrong.
Fair enough. So multi-platform. Okay, React popularized new programming model. Okay, so it makes sense. Function. Okay, Jetpack Compose is an implementation of a React UI model for Android. Okay.
So it does use Jetpack Compose on Android.
As a compiler, I think.
I guess.
Okay, Compose compiler, Compose UI. What is Redwood? Redwood integrates a Compose compiler. Okay.
A design system and a set of platform-specific displays. Okay.
Join.
Hello. We're trying to figure out what Redwood is and what it does.
All right, let's try this again.
Yeah.
So, Redwood's not super important. We can talk about it next time, but the gist of it is that you're writing Compose code, normal Compose, state management, composable functions, whatever, and then just the functions that you call for UI are not Compose UI, they're different. Okay. So in going through this, I started basically refactoring my composables so that one of them had the responsibility of accepting a model object and putting the UI on the screen, and the other one would just return the state object. So this is very much in line with what the circuit guys were talking about last week. They have this separation of responsibilities where, one half of the composable is just dealing with producing data, and the other half of the composable is consuming data, turning that into actual renderable Compose UI. And then once you do that, you like look at a way where you want to be able to test that functionality, in like a unit test or whatever. And so the idea is basically, if we have the ability to run Compose, the Compose runtime on the JVM, why can't we just spin up the runtime, run this state producing composable, and get the state objects out as just values? And so again, last week with Circuit, you kind of saw this when you were looking at the test cases that they were showing. They were showing basically you set up, you create their presenter abstraction, and then they were using Turbine to consume a flow of these state objects and then doing just normal assertions and interactions with it. Behind the scenes, what that's actually doing is running the compose function of the presenter on top of Molecule. So I'm all messed up here now. Can I share my screen through the web?
I think you can. Your face might disappear, but it's okay.
I don't see a button to do it.
Then maybe you cannot. You can tell me where to go if you want.
You're good. Yep. Just scroll down to the top of the README, or the introduction rather. So what this is showing is a very like hello world Compose UI example where we have two sources of data. We have a flow of the current user and a flow of like their balance in some bank app or whatever. And what the composable function is doing is it's subscribing to both of those flows or collecting the flows within the composition and then doing some logic to determine whether to show a loading UI or the real UI. And what's going on here is we're basically mixing business logic with presentation logic. So we have the logic of deciding what to do based on the data that's coming in, which is whether to show loading or the main UI. And then we also have the actual like rendering logic, which is which composables are we showing based on the current state. So if you go down to the next code block, this is how we solved it for the last, like maybe 8 years or whatever at CashApp, which is we have this presenter abstraction. Again, this is like, if you saw last week's stream, you'll be hearing a lot of the same stuff because Circuit has a lot of things from our internal architecture. So we have this presenter abstraction, and then historically we would use like RxJava or something, or even still flows and using operators to combine these sources of data. What happens is like that snippet, it actually still is somewhat readable, but it's a lot less readable than compared to the original Compose UI example. And then it only gets like worse and like exponentially worse. So if you start adding more business logic to it, you have to start encoding it within, flat maps and switch maps and having all these like intermediate values in order to, pass things along through other operators. And the actual intent of the business logic, like the essence of what you're trying to actually encode, gets lost in this sea of operators. And so if you scroll down a little bit, this is sort of the solution that Molecule is proposing, which is, and it's not really Molecule, like this is just Compose sort of architecture in general, but if we have that system, which is what we had at Cash, and we change it to basically look almost exactly like the original Compose UI sample. The only difference being instead of directly putting UI composables onto the screen, we are returning the representation of the UI as a state object. And so that composable that you're looking at is almost identical to the original one. The only difference is now, instead of emitting those text composables, we are returning a state object from this function.
Mhm.
And so what Circuit does is it goes a little farther, and it actually just, it hosts the presenter composable within the UI composable. And that's a little more of a modern approach. Like, you don't need multiple compositions running. You only have one composition, and it's more just like architecture and abstraction. At Cash, our internal architecture is a lot more, I would say, separated, the UI and the presenter. And so we don't have the ability to do what they are doing. And so what we need to do is find a way to run this new data producing or state producing composable function. And the way that we do that is with Molecule. So the bottom little snippet there, you can see we're basically calling this launch Molecule function on a coroutine scope, and it is just invoking that that composable function that we just wrote, and the output of that is a state flow. So what's going to happen when you run that function is the very first composition runs synchronously, and so by the time that statement returns, there is an initial state that you can use to either test against or bind in your UI, which is very important because it means you don't have this like frame delay with rendering, and you also don't have to synthesize like any default states at the UI layer, because the state flow, when you collect that in the Compose UI rendering layer, you don't have to like give it a default state, because the presenter should be the one owning that default. And so you can see right below that, where we're now consuming that at the UI layer, and we just consume that state flow, and we switch on the sealed hierarchy of states. And so it's very reminiscent of what was talked about last week with Circuit, because we have very similar architectures, and Circuit is actually using Molecule for testing their presenters on. It's actually not JVM specific, on any platform, on any Kotlin target. You can use Molecule, but I want to emphasize that like this is the motivating example for Molecule. It was motivated by the fact that we had these presenter instances that were almost entirely RX based. So they were producing observables as their output, and then in our UI layer, we had views, we had Compose UI, we mix and match, and then basically what we wanted to do was introduce Compose at the presenter layer as well, and so Molecule allowed us to do that. But in general, a general way of thinking about it is it's a Compose-based system where the output is not UI, it's just state, and so you can use it anywhere that you want to write code in Compose style, which is much more imperative, rather than RxJava is more like functional, or even coroutine flow is very functional. You can write Compose's imperative style and get that programming model while still getting the sort of reactive output that you can then send downstream for somebody to listen to.
Mm-hmm.
And it's like not at all, the cleverness is actually, the cleverness here is that it's not at all novel. It's actually wildly simple in what it does. So if you scroll up back to like file list, and then keep going, click on so you see how the license.txt has the initial commit in the middle. Click on that. So this is the very first commit of Molecule. Scroll all the way to the bottom. All right, up a little. So that file right there, the one you're looking at, is the original version of the entirety of the molecule library. It is maybe 30 lines of code. And so all we're doing is we're just setting up, we're copying the boilerplate setup of Compose, the Compose runtime, from Compose UI. Like we basically have literally copy pasted that. And then that's the first like 15 lines or so. And then if you scroll a little bit, the try block and the while loop is sort of like the only interesting thing here, which is basically we set up this. It's different now and how it works, but this was the original thing where we're basically just setting up this system where we're doing like a suspending polling of state and then emitting that into a state flow. Or in this case, it's actually just a flow. This is before we even had state flow support. And then at the very bottom, you see there's this weird looking thing, which is this applier. And that's because if anyone remembers from when we talked about how like Mosaic works, or I think you touched on this probably with Leland, applier is like the way that Compose builds trees in order to render them. And in this case, we don't have any kind of tree. We're just returning objects, like state objects. There's no nodes that are available for rendering. And so we have this like empty applier. And this is like the entirety of the library. It's just taking the Compose engine and turning it on and allowing it to record the values as it decides that your function needs recomposed and a new value is the result of that, emitting that into a flow or eventually a state flow that you can then consume. There's like almost nothing to the it's a little more complicated now. We've added like features and stuff, but the essence of like this initial commit is that there's like nothing wildly novel going on here. We're literally just setting up the Compose runtime so that it can shoot out these state objects, and then what you use it for is entirely up to you.
Ivan, did you have a question earlier?
Yes, I mean, it's gonna sound very silly, but so there is no view model anymore, right? So you're not using the Android view model for this because this is also multi-platform, or I'm getting it wrong.
We've never used view models at Cash. You certainly can use this within a view model. Your view model basically would launch one or more of these, molecule functions, and then you would just hold on to the resulting state flow as properties, and then in your Compose UI. So if you go back to the repo, like the top of the repo or whatever, we have two samples. We have one sample which is sort of like our architecture.
Sample view model, okay.
All right.
Yeah, and the other one is like how you would use molecule in a I don't know what you call it, like a traditional Android application.
Yeah, I mean traditional with the idea that there is a view model, but there is I mean, because I'm asking because usually I don't start from greenfield projects, so I end up on a project that has already architecture components and things like that. So view models are going to be there, and I was just wondering if this thing is like a substitute or it can be integrated in or does it make sense to migrate away from a view model, because the view model also does the persistent the configuration change thing. I mean, there are things that are abused maybe from view models, but they are there.
Yes, so this is very much a direct replacement for effectively the combine operator on Flow.
Okay.
Or really any operators that you would use with one or more flows coming in. So this was kind of one of the questions that was asked. It is basically just like a super powered way to combine any amount of inputs into a single state object without having to create these like crazy deeply nested, very opaque operator chains that encode your business logic, and instead use normal if else's and for
Yeah.
loops and function calls. And so yeah, unfortunately, like there's some subtlety around integrating it with view models, which is why this sample is a little more, I would say, complicated than it should be. But if you click on the presentation logic one, I believe this is a view model subtype. Yeah, so we basically just have this helper. And the idea is that you would either have a view model that just had a single state flow that you want to then bind into your UI. And that's
Yep.
what this is setting up. But if you have a view model that has 3 or 4 state flow properties that you're getting from database queries or whatever, like you still could go and use Molecule to combine some of those, to start to combine some of those together, while eventually trying to get to this single state point. But you can see that you can see here that it's again very similar to what you saw last week, where there's a model object, there's these event objects, and
Yep.
it creates this unidirectional data flow thing. And this is nothing specific, nothing that Molecule forces you into. The only thing Molecule is doing is running Compose. And so like we're showing this because this is sort of like the pattern, that the architecture that is gaining popularity. But you don't have to use unidirectional data flow or anything. Like Molecule doesn't care. It's very much it's like a brick. It's a tool that you can use to build a house or a wall or whatever you want. Like it's a very primitive tool that you can use in very different ways. And so I don't want this sample to be like misleading, that you're forced into a particular architecture or data flow pattern.
But it's clear that it's not pushing you to a very specific architecture, because, for instance, the first thing that I can see here is that the model is just a data class. It's not a sealed class. Like we usually see sealed class for loading content, the usual stuff. Here you have a simpler model that is just one data class. And because maybe, I guess, the focus that you want it to be on something else instead of guiding on the UDF implementation, right? I mean, that's the feeling that I get.
We do a little bit of a disservice that there's not more samples that show different use cases. Part of that is because when Molecule started, we actually had to build the Compose runtime ourselves, because Compose was Android only. And so in order to run on the JVM, we had to build the Compose runtime for the JVM, swapping out things like Android tracing and a couple of the Android specific dependencies that we had. And our use case internally is replacing our Android specific RxJava based presenters with Android specific Compose based presenters. So everything started off as very Android focused and focused on sort of this presenter case, or like the UI logic sort of layer. But then it's only within the past 18 months that this has really changed. And that's all because of the work that JetBrains has been doing about publishing the Compose runtime and Compose UI for multiple targets. And so that allowed us, once they started doing that for the JVM, we were able to switch to that. And then once they started publishing for native targets and for JS or whatever, we were able to basically just build on top of that. And by build on top of that, I mean all we had to do was add the same targets in our build file, because nothing about Molecule changes when you're running in JavaScript or when you're running in Kotlin native. It's just setting up the Compose runtime.
Yeah.
But what we failed to do, I guess, is sort of add in the samples that show different use cases. Because if you're building a web server with KTOR that runs on the JVM or runs on native, and let's say you're providing a WebSocket endpoint that sends updates for state changes or whatever, and it's aggregating a bunch of database queries or external API calls, you can use Molecule to write that as a composable function and use it to compose those data sources and have the output piped into the WebSocket rather than having to do all that state management or do a bunch of flow combinatorial operators. The use cases are really only limited by your imagination as to where you can use them. Anywhere you are doing state management, you can use Molecule. Whether or not you should use Molecule is then the decision that's up to you as to whether it's appropriate or not.
Well, I mean, I think you can always try and spike it, for instance, right? I mean, it's a common thing to say, okay, let's give it like a week.
Yeah, it's very much it's very much a primitive akin to like a flow or a state flow. So if you're having a conversation like, should this just be a regular string property, or should it be a state flow of string? That's sort of like a decision about whether something is observable over time. And then the question, Molecule is a primitive, like when you're combining things together, it's like, well, am I just taking two properties and combining them once and returning a new property? Or am I observing two observable things or more, combining them and returning another observable thing? You can do that with flow operators, ArcJava operators. But as the logic of combining those things gets more complex, the way that you write it in Compose is so much more easy to both write and also read in comparison to if you do the big operator chains or whatever.
Can you walk me through this? Sebastian is showing this PaperPix presenter, right? So I see that there are a few things. I think this service is providing you with observable things, right?
So we have sort of like a data layer, a presentation layer, and a UI layer. The data layer would be abstracting away the network, database, any kind of persistence or whatever. And then this composable is the presentation layer, where we're combining multiple data sources. We're performing actions based on events. So you can see, I mean, if you look at this, it looks like normal Compose UI where you have effects
so you're launching effect because you are in a composable, and that's how you use coroutines, right? So that's the idea, right? So you don't do launch, but you do a launched effect because you are in a composable. So that's the idea, right? And then is it so for the thing that I understand? So breeds is a member of a list, so it's something that's going to change over time, and it's changing because you are listening to the service list breeds, right? So that's one flow of data that comes in. Am I correct?
Yeah, so I didn't write this sample. What it looks like it's doing, so it's a screen that loads a set of, I guess, dog breeds, and then for each one it goes and fetches an image for that breed.
Okay.
And then you can, I guess, click on one.
And then, but then I saw, yes, now there is a return, and that's the UI state that then you are sending to the UI rendering part, and then you show it, basically, right? So the events collect is just is like a normal flow, I guess.
Yep.
Okay.
Yeah. So and again, this is the thing that this sample is just doing from last week with the circuit guys, you also could do the circuit pattern where the model object that you emit at the bottom has lambdas in it, and those lambdas are callbacks into this function. And yeah, like, you know, circuit gets away with, not gets away with, but their design is such that the UI composable basically hosts the presenter composable. And so they only need the compose UI composition to be running, and it runs sort of all the layers. For us, our architecture has a very hard line between those two layers, and so we cannot pass a composable across them. And so we need the ability, Molecule allows us to run these pure data compositions entirely on their own, and then feed their outputs into the UI layer. And so actually what we have is we've migrated a large number of our RxJava-based presenters to Molecule-based presenters without ever touching the UI rendering. And so the Compose presenter is actually driving view-based UI layer in, I would say, an overwhelming majority of our screens. The majority of them are still view-based because, you know, they're not broken, so why change them? We do have Compose UI-based ones, but there's this, because of our architecture, we have this abstraction, this hard abstraction between the two, where we can have RxJava presenters driving Compose UI views. We can have Compose presenters driving legacy Android views. Or we can have, you know, Compose driving Compose UI, or we can have RxJava driving views. Or, you know, if something else were to come out tomorrow and we wanted to try it, a different thing, we would be able to do that because of how our architecture abstracts away the boundaries between these layers. And so that's really what Molecule was originally designed for, was just driving this composition so that you could pipe it to whatever you wanted, whether it's a WebSocket, legacy Android views, it could be HTML in the DOM, it could be the terminal if it's a Kotlin native command line application. It's just, yeah, it's this like tool that you can now use for composing state anywhere that you have state that needs composed.
But I mean, it's fascinating the fact that you can use the Compose runtime to actually feed old XML views.
Yep, because ultimately the output is just a model object, and that model object just goes, it can go wherever you want it to.
But it's a model object, but it's a stream, right? It's a flow in a way. So how is it compatible? What do you do then in the XML world in a fragment? I guess you use fragments, right? Or views? No, fragments. No, and you have views probably. So how do you observe that? Come on, man, give me a break.
That's gonna be spicier than the 2-space question that this person.
No. But I'm pardon me. So that
it's a good question. Yeah, the answer is that this Broadway library that we have internally essentially takes care of collecting the flow from the presenter, and then our UI layer basically doesn't see any reactivity at all. It just has like a set model function. We have an interface that's called UI that just has a set model that takes, you know, a type of T. And so the view, actually, if you go to the UI file in this sample, does it look like that?
1 second,
instead of me
having
to hand wave and explain.
Okay.
No. So it's Compose UI, of course. Basically, I'm just getting.
Maybe there is another sample with a legacy.
Yeah, try that sample. I'm curious what it's.
There is
less
view.
layout. There is less layout.
Yeah.
So
yeah, there you go. So that's a view binding.
Oh, man.
If you look at so this is obviously, this has no like library enforcing the architecture. And so the boundaries here are sort of arbitrary, but if you go to the activity, you can kind of, you'll be able to see the individual responsibilities. If you click on the activity, please. I hear you typing in chat over there.
Yeah, sorry.
People
are asking questions.
I know.
yeah.
I'm doing a bad job of addressing them too. So yeah, so we're setting up the view with it, which is a view binding. And then we essentially do this like two-way binding between the layers. And so the UI layer or the rendering layer exposes a stream of events, and the presenter layer exposes a stream of models. And so we're just sort of creating this two-way binding. We take the events and we pass them into the presenter layer, and then it produces a stream of models that we then collect and bind back to the UI layer. And so this file, which is like, 15 lines or whatever, is basically showcasing like what the core of the Broadway library that we have internally does. It's very similar to, again, Circuit last week, is when you navigate to a screen, we have these UI factories and presenter factories. It goes and looks up the associated, UI, which could be views, could be Compose UI. And then it goes and looks at the presenter, which could be molecule-based or ArcJava-based. And then both of those implement interfaces, which are like single function interfaces. And it essentially does this 15-line dance where it subscribes to the events from the UI, passes those to the presenter, gets the model stream from the presenter, and starts collecting that and passing the latest value into the UI.
Yeah.
So the UI layer is very, very unaware of what's going on. It doesn't take a stream, it just takes the current model.
Yeah.
And that facilitates all kinds of fantastic things like, paparazzi testing. You have your UI layer, you just set a model on it and call snapshot, and now I can, test what my UI looks like in all kinds of cases without having to spin up any kind of view models or presenter logic or anything. The presenter is nicely isolated, where it's basically a giant pure function of events coming in and models coming out. That is trivially unit testable on the JVM. And that, again, is what Molecule allows us to do. We can run that composable function on the JVM, and then we use Turbine to basically test the models that are coming out and asserting, on their values or whatever. So you get this really nice architecture that has, testability is like a first-class design attribute, and you get the ability to, in terms of the architecture, you get the ability to change what libraries you use. We can rewrite a screen from views to Compose UI without ever touching the presenter layer, or we can rewrite a presenter from ArcJava to Compose without ever touching the UI layer.
And this is great for, like over time technology improvement, right? Technology migration, because as you said, something new came up. Maybe the new screen, we go with Molecule right away, and previous screen, old screens, maybe we need to fix something and somebody has a bit of time. Let's try to replace ArcJava, or no, I want to do a bit more UI today. I want to do some Compose UI. I want to do this piece of the UI from XML to Compose without changing the rest of the pipeline. So I think this is very powerful for, also keep people engaged because this prevents you in a way, or gives you the opportunity to keep things funny, like you don't have probably parts of the app that you don't want to touch never again because they are ugly, they are hard to whatever, how to work with. I feel like this gives you the opportunity to say, okay, I want to improve this little thing here. And today I'm in the mood of UI stuff, and I can do the UI part. I don't know. That's how I feel it.
Yeah, and I would say, in my opinion, the RxJava that's in our app is a much greater liability than the Android views that are still rendering screens in our app. The RxJava has business logic that's just encoded in crazy operator chains or nesting or both. It has side effects where like a stream will side effect out into like a behavior relay that then feeds back into it's like there's all kinds of just emergent awfulness that has come from making everything RxJava. That certainly we probably should have foreseen 10 years ago or 8 years ago whenever we started using RxJava. But it just got so bad. And then rewriting that stuff into Compose teases out all kinds of things like, Zach was talking about these states that are impossible with Circuit and how their design sort of makes it impossible for certain behaviors. That is like compounded even more with RxJava, where you have these combinatorial operator chains that produce model objects that are nonsensical, and teasing that apart into composables makes that all, and like sealed types and all that stuff, makes it all very apparent, and you find all these kind of weird states. And so that has been a huge boon in terms of just making the business logic of our apps much more easy to understand and change over time. Whereas, the view layer with Compose UI, like, yes, Compose UI is like so much more fun and certainly dramatically easier to write and maintain over time. But also, a lot of our UI is mostly just like a design system that's static and isn't really changing. And so the view-based screens in our app are sort of fine. Like we know they're not gonna break, and if we have to change something, you're not gonna have this like ripple effect like you can with RxJava, where uh, it ends up like affecting other parts of the view as much. And so yeah, this was like a really useful tool to break our addiction, I would say, to
Well, I mean,
to these huge RxJava presenters.
when you have a hammer, right, everything is a nail. You end up using it for everything. But I wonder if when you do the conversion and you mention side effects into behavior subject or things like that, you don't end up with something similar that you have a shared flow and you're just throwing things to a shared flow instead of a subject, right?
Well, yeah, what those things, so side effecting side effecting from a RxJava stream is okay if you're truly doing a side effect, which is like logging analytics or logging to Logcat or something that's actually not a primary effect or like a direct effect. The side effects I'm talking about are, yeah, like within a map operator, somebody would be calling like relay.emit with the value, and then that relay is like subscribed higher up in the same stream of operations.
Oh wow! So you are kind of combining yourself, basically.
Yeah. It's like we've determined, and this is of course all of this stuff is like very emergent over many years, and tens of developers
it made sense.
Touching these
it
files.
Made sense.
Right. Every minor change that was made was probably fairly innocent, and then the result is this like pile of garbage that is nobody's fault. It's just sort of like what happens if nobody's being like really paying close attention or whatever. And so that sort of like feedback loop kind of thing, where you need to send some other state back into your like state machine, is actually not terrible with Compose, because then that just becomes like a state object that's remembered within the composition, and then you're within like an effect or something, and you're writing into that state object. And so the next time, and that will like dirty the composition, it will cause Compose to recompose, and then you get this sort of like fairly normal behavior, rather than with RxJava, like the way you should be doing that is very different. That's like a big time anti-pattern feeding back into yourself, at least that way. And so, yeah, you still can have those things where a transition to one state causes an effect on another state. But with like the programming paradigm of Compose, that just doesn't become this like gross spaghetti mess of dependencies.
We saw it before, right? You have a few val by remembered at the top, and they look like imperative code, and it feels less dirty, as you say.
I keep looking at the wrong camera when I'm talking.
It's fine.
Okay, real quick, I want to answer some questions. 2 spaces and 4 spaces, both are wrong. Tabs is the correct answer, and I'm not joking about that.
But then how are the tabs represented?
If you look at all my personal projects, they now are all using tabs. And with the editor config, you can specify how wide you want the tabs to be. So if you want 4 and I want 2, we both can have what we want. How's that for spicy?
Yeah, that's I actually noted down. It's minute 58. There is a tab versus space chapter in the video description
corner now.
So I think if I only use Android and use Compose, do I need Molecule? Ultimately, I think it depends. Yeah, if you have the strong architecture like we have, where you want that boundary between the two, you can drive the presentery logic with Molecule and pipe that to the Compose UI. But I think like even if you're not using Circuit, the Circuit pattern, it works really well, which is just have a composable function whose responsibility is just state aggregation and management, and then have a composable function that its sole responsibility is taking state objects and turning them into nodes that render. And then you could just combine those two in a higher up composable function that just calls to the first one and passes the result to the second one. And that immediately means that the preview annotation is going to be so much nicer on the UI function because there's no business logic and state within it. You can unit test the presentery side of that using something like Molecule on the JVM rather than on a device. It's just like the design pattern of separating those two responsibilities is a good design that yields a bunch of benefits. And then Molecule can help you realize those benefits by allowing you to test the state producing composables on the JVM rather than on a device. So, but again, you don't have to do that. You could run them in an instrumentation test, and that would work just fine. What else? What did I miss?
I'm just looking. I mean,
fragments.
So
there's the fragments
from yeah. Is it a question though? So the question that I have, maybe it's a bit more internal from how you do things at CashApp. But how do you manage the configuration changes? Is it Broadway doing it, or you're completely, or you have your app locked in portrait and fuck it? I mean, how does...
Well, rotation is not the only configuration change, I will say.
Yeah, I'm kidding, but that's the most used one as an example.
So yes, we again, I'm just repeating a lot of things that they said last week, but we have a Broadway, this library manages our backstack, and each entry on the backstack is associated with a sparse array of parsellables, which is basically the type that Android uses to serialize state. And then whenever a configuration change happens, we do two things. One is that we pass the current backstack across there's this thing called the non-configuration object that you can pass through an activity. And this is basically an object that you want to just survive the configuration change. It's a really cool API, but it doesn't compose well. And so, ironically or whatever. So this is like the mechanism that ViewModels use. So every view model goes into this like view model, I forget what the class is called, that holds all the view models, and then they pass that object through this non-config object. It's literally called non-config object. And then they grab it on the other, you can get it on the other side. So in the new activity, you get a reference to the same object that you passed through. And so for simple config changes like light theme to dark theme, locale change, maybe somebody has resizable activities. But yeah, so the process is not dying. Your activity is just being recreated. And so what happens is like all of the active presenter and the entire backstack is just passed through as an instance. And so we don't recreate anything. The only thing we recreate is the UI, because something like the language could have changed or the theme could have changed or whatever. But the presenter can stay running. And then, so that's like the remember retain thing, I guess, that Circuit does. But then because we store everything in sparse arrays of parsable, those are the types that can get put into a bundle. And so if there actually is process death due to like memory pressure or whatever, you take a video call, I'm like trying to send money to my friend in cash, and like he video calls me, and that uses a ton of RAM. And so Android's like, I gotta kill CashApp. We do get a callback, and that list of sparse arrays of parsellables all get put in the bundle. And so when the app comes back, we just pull that out like normal save instance state stuff. And again, this is like the responsibility of the library. You don't have to worry about this or think about this. In the same way that Circuit is doing this on your behalf, Broadway is doing it on our behalf. And then it will recreate the active presenter and the active UI when the app comes back. And again, like Zach was saying, the remember savable, composable function, we do have that working in Molecule. So our presenters can save things across config changes and process death. So if they have something important, like you're in the middle of some sort of like flow, they can save that state, assuming that it's actually savable, and that will be recreated and reinitialized when the app comes back.
Okay, thanks. I mean, I think it's in the case of Circuit, they can't use sparse array or things like that, right? Because of the multi-platform, or they have different implementations. Sebastian, I can't remember actually. They use something Kotlin generic, but I do remember that they use ViewModel behind the scene on Android. So I think they have different implementation.
The Android implementation uses whatever is on Android, and the other implementations use whatever is available on the other platforms.
Yeah. So Circuit, the reason you use a ViewModel is if you're a library, because you don't want to The only way to use the non-config object directly is with an activity subclass. And so for us, cache has always been single activity. So we've always just had like that single activity where we could do sort of frameworky things. And so that's why our navigation is like centralized and hosted within that activity. And so it can get passed along that non-config instance directly. If we were to make that open source, we would have to switch to something like ViewModels to get that benefit. Because otherwise you would basically be telling people, hey, subclass, Broadway activity, which is like a very 2013 style library, like subclass my activity kind of thing, which nobody wants. And so unfortunately,
well, because they
ViewModels,
already have base activity and base
right,
fragment
they have
and
their
base
own,
ViewModel.
yeah, or multiple activities. Yeah, so unfortunately, you have to use ViewModels, even if you're not using ViewModels, but that's just, it's just what you got to do.
So spoiler, I mean, so is it like your main activity, because it's single activity, is it like 3 million lines, like the one that I was used to to work with, like, or is it like a normal activity just as an entry point?
Yeah, it's probably a few hundred, but I would say almost entirely everything in it is setting up other composable mechanisms. Yeah, so we have, our composable UI and presenter framework that you can add screens into. We have a composable like worker framework, which is sort of like background jobs that can like observe the activity lifecycle and run and do things in the background. All kinds of stuff. Yeah, all kinds of stuff of just like setting up reusable things for the rest of the app. Nobody goes into the activity and like writes logic or like, actual like cache code or anything. So it is big, but it's all just setting up a bunch of reusable stuff.
On backpressed, do you imagine going there like 10 years after the first commit and say, I'm going to implement the on backpressed here.
Yeah, and that's the other reason is that it gives us hooks into stuff like that. So the backpress stuff gets passed into Broadway, and then Broadway checks the backstack and does the right thing when the hardware back key is pressed, or hardware.
But it's fascinating how the more we talk with friends that build a library and build complex app, and the more you feel like a lot of stuff is missing on Android, and everybody's kind of working out their own solution that they can look similar, but they are maybe very specific to the domain or specific to the people that at that time worked on the library, and now you have a sort of self-vendor lock-in kind of thing. That it's very fascinating for me. I'm working on.
I like that.
Yeah. No, but I mean,
I'm not
sounds
joking.
weird.
Like...
Sounds weird, but but imagine somebody that comes in today in CashApp, and there are things there, as you mentioned, that the app has been there for like a long time. So maybe a solution to that problem was built, I don't know, 6 years ago, something like that, right? And now you are onboarding people, and you are gonna train them with all the knowledge and the history of why we have this, and then maybe you have people asking, why don't we use a view model, or why don't we use the navigation library, right? Because also with Circuit, they were like, oh no, yeah, we build our own backstack. It's super simple. It does what it does, and that's it, right? It's 100 lines of code and does everything. And now I'm constantly updating the navigation library every week, and I still don't have those fucking animations, right? and you start wondering what's going on, there, and why it feels like we are not solving the right problems as from Google giving us libraries point of view?
Yeah, it's we do, so like PY wrote a blog post about fragments in like 14 or 15 or whatever. And he did like a deep dive into, like, we tried fragments hard in like 2012, I would say, late 2012, 2013, like right when they came out. And then we're immediately burned by both their terrible architecture and just being riddled with bugs. And so we like scaled that back, and those things were somewhat fixed. The bugs absolutely were fixed over time. I still think they're problematic architecturally. And so PY has this like nice blog post that we can just sort of refer people to when they ask why we don't use fragments. And then we've done like similar things with, you know, view models and navigation, where we've done this analysis of them. We've determined that we, you know, don't like them for various reasons, but then we have failed to do like the last step, which is to write it all down in one place that somebody can go, because inevitably every, you know, 3 or 4 months somebody comes in and asks why we don't use navigation or view models or whatever. And it's like, I promise there's good reasons, and we looked at them in depth. We just don't,
But that's actually your superpower, because you have credibility, and you know, I will trust you just blindly. I work with you. I work at CashApp. I really don't care why you don't use. If you say we don't use it, you know what? Sold. Fuck it. I don't care. But you know, if you imagine no, but I'm serious, because
You're easy
if
to
I try
convince.
to, no, but because you know, there is so much stuff on the table that you don't want to mess up the tiny bits. But then imagine somebody else, you know, introducing molecule or introducing circuit in a project, and then 6 months in, you know, new people come in, and I need to do the sales pitch of, you know, I mean, I can do the even thing and say, oh, we have an architectural record, you know, the IDR, how is that, the architecture document record, whatever it is, decision record, architecture decision record, where you put everything down, you know, we tried this, we voted, and you can play it cleverly, or probably just a bit smart ass kind of thing. But that's a legit concern. You know, at some point you will have conversation with newcomers that, even from a political point of view, they just want to challenge you. And you know, there is only one Jake Wharton, so the rest of us has to have, you know, arguments.
Yeah, well, there's a few people there's a lot of people that work on this stuff other than me, that's for sure. So we internally historically have had like two terms around our use of different libraries and architectures, which is, there's like squareware and then there's weirdware. And so if something is squareware, it's like we have to build this because it's specific to, you know, what our company is doing, our business is doing, or like there's a reason that we have it. And then there's weirdware, which is like, we built this thing because we didn't, you know, we either there wasn't anything existing, but now there is, but we can't switch to it because it's basically like tech debt or whatever, or it's just somebody, don't. Yeah. So like, yeah, it can be very sort of humbling to go and look, and you basically have to evaluate whether we're doing these things just to be different or whatever, or I would say in general, we try really hard to use things that are like sort of community available and used. And so, you know, we don't want to maintain our own navigation stack, and we don't want to maintain all these things that are, you know, bespoke and custom to our app. But our requirements are, so there's a question, I swear there was a question, something like, maybe it was about navigation, but like, we can't, one of the reasons that we can't migrate to something else, either navigation or even like circuit, which we actually really like, obviously, because it's essentially a derivative of what we already have, is that our requirements for the app are fairly. Oh, the question was, why isn't Broadway open source, or is it open source?
Yeah.
It's not open source because it contains knowledge of product-specific things in our app. We have this concept of essentially like layers, UI layers. So there's sort of like the base UI layer, and then there's these like overlay layers, which could be where like dialogues or bottom sheets show. And in the design system basically mandates things about these layers and how they behave. And so that's a concept that is unfortunately very tied to how things like the back button behaves and how navigation behaves. And so we have to put that logic in the actual central navigator. And so when we try and open source Broadway, or even just tease it out into like an internal reusable thing, there's this problem where it's either going to be a library that just has 3 interfaces, which is the screen interface that's empty, it's a marker interface, the UI interface that has like set model, and the presenter interface, which has like the events and outputs, and then there's just no implementations of anything because everything else is like too specific to what we do. Or we could try dragging all of that in, but then we have to build a reusable concept of these layers. And so we would have to like abstract them away into this generic layering system that you could define, and you somehow have to define rules about navigation and layers, and it becomes very it becomes almost like too abstract and too hard to model. And so unfortunately, for better or worse, the navigation logic is like just tied to our design system rules, and so it makes it nearly impossible to open source in any usable way. But I would just tell people probably to go use Circuit. It's really close. It's really close to what we're doing, and in some aspects, it's actually a lot better than what we're doing because they had the benefit of designing it from scratch and only supporting Compose UI as the rendering layer, whereas we very much still need to support the Android view system, and that imposes a bunch of things back on sort of the internals. So it's sort of just like the better version, or like a more idealized version of what we have, and I don't think it's perfect. It's not going to work for every single application, but I think one of the reasons that a lot of the libraries that have been successful coming out of Square or CashApp or whatever, one of the reasons they've been so successful is because they don't design for the 100% use case. They design for like the 80% and then try and give you escape hatches if you have to do different things. And so hopefully that's sort of where Circuit ends up, is that when you have to do things that are more advanced, like potentially this layering concept, and we also have more complex interactions with our backstack. They only have push pop and whatever the reset one is. Ours is a little more complicated. We have more operations that you can do, more manipulations. So yeah, it's probably never going to be open source, and I think that's okay because Circuit is basically the closest thing that we'll get.
So, or you can open source also the design system and the business logic from Cache, and everybody just embraces how the back stack works and how the bottom sheet works on Android. But jokes aside, so would you say that with the right punches and kicks, you will be able to replace Broadway with Circuit, like in a given enough time and enough swearing and cursing and people?
I'd say it's definitely it's definitely a nice future that we could work towards. I think I'd be okay if it never happened. But Circuit has been made better because of our experience, and certainly a bunch of other people have had input into it. I don't mean to say that it's like only us. Zach is very flattering when he talks about it in terms of our influence on it as a company. But yeah, it would be nice to continue to work together and to sort of like skate towards the same goal. And maybe we do get to a point where all of our view-based UIs have turned into Compose UI, and all of our RxJava presenters have turned into molecule presenters. And so we can sort of like simplify the equation of Broadway and turn it into, Compose only. And then we could do sort of like the further simplification where we build our layering system on top of I guess, Compose UI. Somehow it doesn't seem like an impossibility. I wouldn't say it's like a goal, like a primary goal, but it's like it's a nice thing that we can sort of have spinning in the background. Like we'll be working towards each other, and if we happen to meet in the future, that would be fantastic. But I think ultimately our near-term goal is much more that first step, which is like eliminate all the Android views and eliminate all of the RxJava, because that then simplifies a lot of things.
The way you talk about it, it feels like the return of investment of getting rid of those RxJava streams are like serious. It feels like a pain to reason about, and the return of investment is going to be massive. The simplification that can come out of it, it feels like you really want that to be the priority. If it's like a painful thing.
Yeah, there are people we have like an internal system for these large scale refactorings, and so there's like a tracking dashboard that has all of our presenters, and there's like this reward system, so the people that migrate the most presenters from RxJava to Molecule get like things sent to them. And so we're actually tracking
Spoilers,
pretty well.
Cars. That's how he got the BMWs.
I wish. Yeah. So we're actually pretty close to like achieving that goal. It's
nice.
Not a crazy far away one, whereas like using the view system and migrating that to Compose UI, much farther away. But yeah, those are things that are much more near-term goals that are more realistic, and maybe in the end, turning everything into Compose at the presenter side and Compose at the UI side means that we can use part of Circuit, maybe not all of it. Start to use. Maybe we have to have our own navigator and the thing that does like the layering, the layer presentation, but we could reuse other aspects of it. Like that would be a nice. That would be a nice, conclusion. But yeah, it's hard to predict that.
I bet, especially with your app, money, a lot of money involved in any way, in any sense.
Yeah, it's and then well, not to go back to the beginning of what we were talking about, but the Redwood stuff is also comes into play a little bit because it deals with to quickly summarize what we're doing with it. We're basically it's really easy to talk about because if we think about what we've been talking about with Compose-based presenters separated from Compose UI-based rendering. Now, Compose, the core of Compose is multi-platform, so it can run natively on iOS, can run JavaScript or WebAssembly in the browser. And so what Redwood is doing, Redwood and this other part of it called Treehouse, they're sort of like the same thing. What we're essentially doing is taking these Compose-based presenters and we're moving them into a JavaScript engine within the Android client, talking to the native Compose UI. And what this allows us to do is that we can update the presenter. We can change the presenter, send out a PR, have it go through CI, get compiled to JavaScript, deployed to our CDN, and updated in the app with a turnaround time of like an hour, rather than 2 weeks plus a 1 week rollout of the APK.
Okay. So you're basically shipping an app, like without shipping an app.
Yeah. It's sort of like if you think of Molecule as like, you take the business logic out of your Compose UI layer and you run it separately, either within Android or on the JVM. Redwood is like, well, I'll take that a step further, and I'll take that business logic and I'll just move it into JavaScript or WebAssembly virtual machine running in the app that you can then update out of band of the App Store. And what we're also doing is we have that same JavaScript engine running in our iOS app, and it is talking to the native iOS views. So it's putting iOS views on the screen with the same presenter logic.
Well, I mean, it was something similar back in the day for Facebook. They were doing something like this with React, or I'm remembering wrong.
Yeah, the big difference from something like React Native is that the elements that you emit to the native UI are semantic within your design system. They're not like low level. You're not writing like a column with 8 DPs of padding and horizontal alignment and a text with this font and this font size, this color, whatever. You're emitting like a my design system button style equals primary. And then how that gets rendered on each platform is entirely platform specific. And so it may look different. It may look different on Android, iOS, and web because the corners might be rounded different. There might be a gradient on iOS. There might be elevation on Android when you hover over it and click on it or whatever. And so we're not dictating a unified rendering pipeline on every single platform like React Native is essentially trying, or like other cross-platform frameworks. We are deferring to the actual platform native rendering and the developers writing code for that platform to determine what's like the correct thing to put on the UI for that semantic design system component or whatever. So I don't want to get we shouldn't get too deep into that because I could talk about that for hours, but it is the continuation sort of what Molecule started, which is, and it's a little ironic because Molecule technically was, it kind of came from the fact that we were starting to do this and we realized that we could just run Compose and produce state objects instead of having to produce actual UI.
There's a question.
There was a question.
Chat, that I would like to go back to, which was, Stylianos would like to know what's your take on how you've onboarded people to work with Molecule, because they're saying it's very good when you use it right, but it can also be used wrong very easily.
Yeah, it has the same hard learning curve as regular Compose UI. I would say we tend to just teach people Compose UI. We have the same problem with Redwood and Treehouse, where we're now running Compose on iOS, and so we have these iOS developers that they don't have to, but a lot of them want to and have learned how to do Compose so that they can write these multi-platform Compose presenters. And usually the process is that they go through learning Compose UI because all of the same things apply. How do you keep track of state? how do you do things asynchronously in effect, all the certain patterns of like hoisting state out, and having to understand about like why a recomposition happens, and all of those fairly complicated concepts are in Molecule as well. You just don't have that last mile where you actually put, a text composable on the screen. You're doing everything else. And so it really is just learn regular Compose UI, where you have to learn all these things anyway. And then it's just the same. You just don't call text, you return
a model.
Yeah, model object or whatever. And I think, everyone certainly learns differently. And we're getting to the point where we at least have now a lot of examples that people can pattern match on. So if they need to do something, usually there's somebody that's already done something similar, which is sort of a very, common way that we learn. Go find the Stack Overflow post, go find the sample app, go find somebody that's already done something similar, and then do the little tweak to make it yours. That's certainly how I don't profess to be any expert at actually writing composables. I get tripped up all the time on stability and certainly like the keys that you pass into remember or effects to correctly re-trigger them. That stuff is just...
Launched effect, Sebastian. Do you remember my struggle with the double fired launched effect that I couldn't understand why? And at some point I had to give up and try to do it differently, because it was one of those things. Oh yeah, it's just recompose when, and then it doesn't happen. And I was like, why it's not happening? Why it's happening twice? So I really I see the struggle to understand this basic stuff, and it takes a bit of time.
Yeah.
There is another question.
Yeah, go for it.
I would like to ask something. I hear recently many apps moving to a native and web view hybrid to ship apps faster and having something similar to the Redwood you talked about, but leveraging web.
Yeah, we do that as well. Like we have a tax offering, so you can do your taxes through CashApp, and the permutations of that system are so great that the complexity of doing it entirely natively would just take way too long. And so it gets punted out to a web view where essentially a server can be doing all this stuff dynamically. And I will say that that long term, that is something that Redwood and Treehouse are meant to address, is the ability to do highly dynamic things for a user while rendering native UI and getting that native UI look and feel. It's not dissimilar from server-driven UI. So it's in like traditional server-driven UI, you get like a JSON blob of it's like a semantic representation of a screen. You have like a header and then a paragraph and then a 2-button row or whatever. And then what you do is you just take that model object, that JSON object, and you loop over the elements and bind them to native UI. That's like a traditional server-driven UI. And we have actually used this pattern in Cache for a long time, probably 6 or 7 years. And the problem with that is that logic becomes very hard to encode. And so if you have things like conditional logic or input fields where the logic of like what can be input changes, you tend to have to ship that logic in the actual app, and then it gets referenced in the server-driven logic that comes down. So you get like an input field and it'll have a type. It's very HTML-like. You get an input field and the type is like email, and then the client will validate that has like an @ and a period in the domain or something. But if you need to do a telephone number, get to ship an app update first. And yes, for that example, you can do like a regular expression or whatever, but like you start pulling on that thread and it just becomes harder and harder to update the logic for a traditional server-driven UI. And so Redwood and Treehouse try and be a cross-section of traditional server-driven UI and giving up and dumping out to a web view, where you can now ship actual code to the device and run it in a virtual machine, and you can talk to the native app. So we talk to the database to get the logged in user. We can make network calls. We can go through all the things that the regular native code can do, but we can update that logic over time. And so yeah, in that specific example, like for taxes or whatever, where it's this highly dynamic thing, it changes constantly. Certainly year to year, but also changes based on all the things that you have selected on previous screens, and that affects the logic of things farther down. We're trying to basically replace the need to give up and show a web view and allow that to be still wildly dynamic, but rendering using native UI.
Nice.
It's actually, it's a nice effort and it's a nice use case because I mean, at some point you are just like, you know what, fuck it, let's do some CSS that looks nice on mobile and call it a day. But then you're like,
Does it ever though?
No, but I mean,
it works pretty well.
I agree. If you think about this kind of scenarios where you have one logic, one place that can run, you have a server that runs a lot of logic very quickly. You can ship it instantly. If something, I see this stuff changing with the privacy policy and GDPR and things like that. I constantly get email from my provider that says, oh, we updated your privacy policy because now in Brazil this thing is changed, right? So I'm happy because if I had to ship it in the app now, I need to constantly update apps just for the sake of being updated with this kind of stuff that it's irrelevant to my business because it's just a bureaucratic part, but they will force me to release a new app. So you just ship it as a web view and everybody's happy and we can focus on other stuff. But if you can do it better with something like Redwood, it will make sense.
Yeah, I guess otherwise it also gets to the point where just you don't need an app, you just need a website.
Yeah, and that's there was the concern that somebody in the chat was mentioning. I mean, is it really the app that you need, or you want an app, right? It's like,
so why do you want an app? Is it because of the artificial dichotomy that Google and Apple have created between the two? Like, what is the fundamental difference between a native app and a website? And if you start pulling on that thread and thinking about it, there's very little actual difference. They're using the same rendering stacks. They're both using VMs that do JIT and ahead of time compilation. Like there's the only difference is difference that Google and Apple tell you is the difference, and that the restrictions that they artificially put in place to make it feel as a worse experience when you're on the web.
The difference is getting smaller and smaller though as time goes
by. I mean, I love building native apps. I would absolutely throw away every single one tomorrow if the web had the first class support of feeling like a native app on these mobile platforms, because it is the superior and correct way to be delivering these applications to end users. There's no reason that native apps should be a thing.
And I want to put it on the table because Sebastiano knows me. There is also the money side of things. Because if you ship a website, there is no 30% that you lose, right? You can sell whatever the fuck you want, right? and nobody can tell you anything. And don't, as somebody mentioned in the chat, if you, I mean, Redwood, how long can it last before at some point Google says, you know what, you can't actually do this dynamic update because this circumvents the review process. And now what do you do, right? So that's always the risk with the Play Store and App Store. It's tricky.
I think we're, to that specific point, we're pretty well insulated. Every app release, we bundle the latest version of these like Redwood driven screens in the app, and so they do go through review. They are seen. It's basically not that different than. It's actually better than server-driven UI, because server-driven UI, we can essentially arbitrarily do whatever we want and prevent the app reviewers from seeing those screens. We still bundle the screens both for review, but also just for the offline case. So if you start the app and you're on the, subway or in the tube or wherever, the app works. You can still see the screens. And so it's really that we're trying to deliver updates faster than the App Store. We're not trying to circumvent it. We still go through that process.
No. I was implying that you want to circumvent, but that always can be an accusation, and we go back to the credibility imbalance of CashApp versus the average Joe that sends an app to the Play Store, and I got it on my skin. I have a very old app that I keep maintaining, and every now and then they just reject it because if some rule that but it has been on the Play Store for like 6 years and nothing changed. Why today? And then you start sending emails, sending pull strings because you have friends, and they have friends, and I need to play the Italian card because I want my app on the Play Store. Yeah, but that's actually how it is, right? But I'm also leveraging my privilege, right? Because I have friends. So it's a tricky thing. It's beautifully from a technological point of view, but it's also, there are concerns, at least for me.
I would.
I don't even.
Go ahead. Sorry, Jake.
I don't even submit to the Play Store anymore, my personal and hobby stuff, because the requirements have gotten so ridiculous. And even now, the latest one with you have to have 20 testing users before they'll let you go live, which is absolutely unreal. I know everyone's hoping that Apple gets destroyed by regulation, but I hope Google is immediately after Apple, because that stuff is just it's unbelievable. Especially, at least Apple is has always sort of been closed. Every release of Android is taking the hobbyist nature and the empowerment that they gave developers and walking it back. And so it just feels like this really harsh abandonment of their developer base.
I agree so much that I feel that we need to wrap up, Sebastiano, because this is opening up Pandora's box.
We're on a roll with some spicy takes here. I think should we talk about
don't get me started with
politics
the gate.
Let's wrap up with a lateral thinking. If we go all the way towards web apps and we don't have native apps anymore, as you said, Jake, then the OS essentially becomes your browser, and then at that point you don't need an OS anymore, right?
Basically, you still
Chrome.
Are you talking about Chrome phones?
Chrome phones.
I mean, after Chromebooks or whatever. I don't know.
it's just gonna burn the same amount of RAM. I mean,
hey,
make
Firefox
no mistake.
tried to do phone OS things. It didn't work out that well, but maybe it was just ahead of time. Who knows?
Yeah, I mean, well, if you look at a lot of televisions are basically the operating system is just it's all like Chromium.
Yeah. But I mean, we were discussing this the other day, right? Alexa is dropping the FireOS, isn't it? They are gonna ship their own thing with slot machines and hookers, whatever it is.
It was blackjack.
Blackjack. Sorry, wrong quote. But
Well, I
yeah.
will say that Molecule compiles to JavaScript, and so we are well suited to support the beautiful future of every app being a web app.
I love it. I love
Nice.
it. Ahead of time. Anyway, beautiful people. I want to thank you, Sebastiano. Allow me to wrap this up.
Go for it.
So we don't get in trouble with Twitch and YouTube. Thank you for being with us, Jake. Thank you for being with us. Thank you for the support, for the new subscribers and the new followers in the chat. Again, if you have an Amazon Prime subscription, you can subscribe for free. You just need to connect your Amazon account to your Twitch account. You will see a new switch on our channel that says subscribe for free. It will allow us to print things like, you know, the keychain and pins and stickers that you can get for free with our giveaways, or if you meet us at some conferences. You can buy our swag. Check out the link in the description or our merch store. And again, this is going to be on YouTube in 24 hours. If you're watching this on YouTube, please subscribe and like. And Sebastiano.
Yeah, so
What's going on next week?
Next week we have PY, and we're talking about Leak Canary and internals of Leak Canary, and probably performance, because why not?
It took me 10 years basically to actually finally meet PY and actually understand how the fuck the Leak Canary works, because I only get the brrr dumping whatever the file, and then I don't know what to do after that.
Can't find out what's up behind that notification.
Yeah, I mean, how do I fix shit? I my entire career was like, okay, I add Leak Canary to my app, and people are gonna disable it in debug because it's constantly say, oh, you're leaking shit, and nobody's ever gonna fix it. So just drop the dialogue. So yeah, that's a set.
So you were genociding canaries, is what you're saying.
Oh, man, you have no idea. You have no idea. I mean, so I look forward to the episode. Yeah, look forward to the episode. Anyway. Oh man, this was good. It was a nice episode. Thank you, Jake. Thank you again.
Thank you for having me. Yep.
Folks, see you next Wednesday. Have a great one. Bye. Oh, thank you for the follow.
Ciao, ciao.